we're going to take the next couple days and talk about arithmetic sequence. Arithmetic sequence is a sequence in which the difference between consecutive terms are the same. In the sequence, we add the same number to get the next term. So you can kind of see that happening here, hopefully. When I go from the first term to the second term, I'm adding 3. The second to the third, I'm adding 3 again, and so on. So each time we add 3 and we continue that pattern, so on. So again, notation-wise, we should know a sub 1 means the first term, a sub 2 the second, and so on. So again, with this type of sequence, we are simply adding to the next number. So this is called the common difference, okay, going from one number to the next. Now in this case, as we just talked about, it is 3 because we're adding 3 each term. And what happens is we can kind of see this happening by, if I look at the second term, it's 4. And we get the second term by taking the first term and adding 3, which is that common difference. If I look at the third term, which is 7, again, I'm actually going to start with the first term, 1. And what we do is we're adding 2 times the difference. If we kind of think about it, to get from 1 to 7, it's 6. How do we get that? 2 times 3. So 2 times the common difference. And the same thing over here. Because what's really happening is to get from one place to the other, we are adding 3 one time, 2 times, 3 times. Starting again with that first number, which we get 10. So again, we'll kind of point out a little bit that even though I'm looking for the fourth term, it's not that I'm multiplying the difference by 4, but by 3, representing the number of steps it took to get there. 1, 2, 3. We could do the same thing if we wanted to find this 10th term. So to find the 10th term, I'll take the first one and do 9 times 3, which would be 1 plus 27, which would be 28. So if we continue that sequence all the way out, we would find that the 10th term would be 28. The generic formula for this, and we want to make sure we highlight this because this is what we're going to be using multiple times throughout this section, is that we can calculate the nth term by taking the first term and adding it to the multiplication of 1 minus whatever term I'm looking for times the common difference. So if we kind of play off of this a little bit, if I want to find the 51st term of this problem, I would take the first term, which happens to be 1, and I times it by 50d, so 50 times 3. Again, that 50 is because it's n minus 1, and n was 50. So I'm going to get 151. So the 51st term is 151. And we'll do that here. We'll do 1 plus 1,000 times the common difference. We're going to get 3,001. So the 1,001st term is 3,001. The other formula that you'll want to highlight and focus in on is the idea of this partial sum formula. And we saw this a little bit last time. Let me pull this up real quick. But we saw it with sigma, and we did it really long-handedly. So we took this and we added each one and we counted out explicitly each term and added it together. Well, there's actually a formula for this. And this formula says that we can take the number of terms I'm looking for, divide it by 2, times it by the sum of the first term plus the last term. And that can help us calculate all of it. So, in this case, if I want to find the sum of the 51st terms, I'm going to do 51 over 2, so the number of terms over 2, times the first term, which is 1, and we very conveniently figured out that 51st term above, so I'm going to put that there, and then I just plug it in. So instead of having to list one numbers and adding them together, I can just plug those in. So when we reduce this, we get 3,876. We'll quickly do this one, same sort of thing. I'm looking for the 1001. Again, this is helpful because I'm not going to list out 1,000 terms and add them together. Instead, I'm going to take 1001, number of terms, over 2, and I'm going to add the first term plus the last term. Again, very conveniently, we already calculated this. 3,001. When we go to multiply this out, we get 1,502,501. We're going to take a look at a couple of proofs in the next couple sections. The first proof is the summation proof of an arithmetic sequence. And so again, we kind of talk about what that sequence looks like, and we started from above talking about it. If I have the first term, the second term would be the first one plus a common difference. The next one would be the first term plus 2 times the common difference, and so on. So that would just kind of be continue that pattern, and then eventually we'll get to a sub n, but before that would be a sub n minus d, so 1 backwards, and then a sub n minus 2d, so minus that common difference once, minus that common difference twice. And if I want the summation of this, of course what we're going to do is we're going to add this. So a sub 1 plus a sub 1 times plus d, plus a sub 1 plus 2d, and then we're going to add that for however many terms we need, and then I'm going to get a sub n minus 2d plus a sub n minus d, and finally a sub n added together. Now what I'm going to do next is I'm actually going to take the same summation, and I'm just going to rearrange it. So I'm going to take these numbers down here and list them first. So a sub n, then this next one, plus a sub n minus d. And I'm going to keep going, just again reversing the order of this. And I'm going to explain, you'll see why I do this in just a little bit. All right, so then what we're going to do with this is we are going to add them together. So add everything. This is going to become 2s sub n equals, and when I add this together, I'm going to get, this is an n right here, a sub 1 plus a sub n. And then notice what's going to happen right here. The d's are actually going to cancel out. So I'm left with a sub 1 plus a sub n. And then when I get to the next one, this plus this, those two d's will cancel out as well. And we're going to be left with a sub 1 plus a sub n. And then dot, 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 however many times that happens. And the same thing's going to happen here. And this should actually be sub 1 right there, sub 1 right there. And so we're going to get a sub 1 plus a sub n plus a sub 1 plus a sub n, and again a sub 1, a sub n. So here's what we have. All of these are the same. How many of those do I have? Well, it depends how many terms I have. So it's really n number of terms by a sub 1 plus a sub n equals 2s sub n divided by 2. So s sub n equals n times a sub 1 plus a sub n over 2, which is what our formula is. We're going to take a look at these and determine if they're arithmetic or not, and we're going to find the common difference. So what we're going to do is we're going to calculate each one of these terms. So when I plug in 1, 3 minus 4 times 1 plus 2, that gives us negative 9. When I plug in 3 minus 4, and the next one is 2 plus 2, 4 times 4 is 16, 3 minus 16 is negative 13. And then finally, 3 minus 4 times 3 plus 2, that's going to result in negative 17. And if we look at the pattern here, it decreases by 4. So yes, there is a common difference, and that common difference will be negative 4. Pause the video, find the first 4 sequences or terms of number 3 and see if it's arithmetic or not. So we can see the difference going from here to here, 1 to 2 is 1. The next difference is 2 to 4. So you can see that those are increasing by different numbers, therefore they are not arithmetic. So when we look at these as well, we can also find a generic formula for them. And we can use the first generic formula that we saw to play off of that to help us for specific sequences. So what we do is we think about a sub n equals a sub 1 plus n minus 1 times d. I want to know, do I have the first number and do I have the common difference? Well, I have the first number, which is 10. I can easily find the common difference. If I look at each one is decreasing by 5, so that we do have, which is negative 5. So I plug that in. And I distribute and get 10 plus negative 5n plus 5, which is 15 minus 5n. So this will give me a generic formula for the sequence. So if we look at this one, it doesn't give us quite all the information. It tells us the 5th term and then to the 15th term. Well, we'll kind of think of 190 as our starting term and think about how many times we need to move to get over there. So 1, 2, 3, 4, 5 times the difference, which we don't know, and that's going to get us to 115. So then I'll subtract by 190 and get negative 75 and divide by 5, and I find out the common difference is going to be negative 15. So, I mean, really what we could do is we could subtract and then divide. Okay, that's really what this is, to kind of find what that common difference is. Once I find the common difference, okay, so I'm going to find the common difference first. There's multiple steps to this one. Then I want to find a sub 1. A sub 1, we're going to again kind of use that formula we start with and fill in what we have. So we have that for the 5th term, we have 190. We know that we don't know what a sub 1 is actually. We got to find that out. And then we know that if this 190 is the 5th term, then that's 5 minus 1, which is 4, times negative 15. So then you're going to get 190 equals a sub 1 equals plus negative 60. A sub 1 equals 250. So now I have the common difference and I have a sub 1. Once you have that, you're going to start writing the equation. Again, we go back to that generic equation. To find the nth term, I'm going to take the first term, which we found was 250, and we're going to add n minus 1 times the common difference, which is negative 15. I'll distribute the negative 15, so 250 minus 15n plus 15 equals 265 minus 15n. So this will give us our generic equation to finding those terms.